At Simio, we're in the business of showing you the future. Our intelligent technology gives you unprecedented insight into complex systems to identify and solve today's inefficiencies and tomorrow's challenges. The Simio Solution provides a low-risk opportunity to drive transformational change. Our true digital twin models capture all the constraints, business rules, and decision logic that define the operation of your system. When powered by your data, easily evaluate unlimited scenarios and deliver optimized solutions. No matter what industry you're in, eliminate your greatest operational process and scheduling challenges with a Simio digital twin. See your future success, Simio.
Perfect. Welcome everyone to the Simio Solution Series 2023. My name is Dan Vasilini. I will get into the presentation here in a second. It looks like we have a pretty good crowd out there, so we will go ahead and get started right away. Today's session is on selecting modeling techniques for varying project objectives. Once again, I am Dan Vasilini, VP of Global Sales over here at Simio. Doing most of the talking today is going to be Drew Rose. For those of you that have attended sessions before, you may see one new thing throughout my presentation today, and then I will bring it up at the end as we are ending as well. There is a QR code, top left side of the screen, and it's going to be in different spots on some of my slides here. I've tried to put it out there so it jumps out. It is nothing more than a QR code to get some feedback on our webcast. So it's kind of like a survey to follow up with. So if you want to do that, scan it in now. You can review after the session is over. But I will bring up the QR code one last time when we were finishing up today, just in case you didn't get it earlier. So, a few housekeeping items before we get started today. Today's session is being recorded for replay purposes. If you'd like to rewatch the session or suggest to a friend or a colleague in the future, it will be on the Simio's webpage shortly after we are done today. And when I say shortly, usually we get it up within about 12 to 24 hours, depending on how the download and everything goes, but it will usually be up sometime before Monday. And it'll be right on the homepage of the Simio webpage. It'll be on a drop down as well for under webcasts. Be aware, all participants, you are on mute today. If you'd like to ask a question, you should see a GoToWebinar dashboard somewhere on your screen. On my screen, it's on the right side. If you've moved it around, it might be somewhere else. In that dashboard, there is a question box. All I would ask is if you have a question during today's session, just type it in the question box and we will get to those questions. If the question is relevant to something that Drew is talking about and I have the opportunity to interrupt him, I will try to ask the question when the question comes in. But if it's more generic in nature and can be addressed at the end of today's session, I will leave it at the end. Drew's planning to talk for probably about 40 minutes today, so we should leave some time at the end for Q&A. As I just said, there we go, Q&A. All right. As far as future sessions are concerned, just so you have them on your calendar, we are doing these. If you have, like I said, if this is the first time here, maybe not be aware of this. If you've been here before, you've heard me say this before. Our sessions, we have them on the second Friday of each month. So our next session will be on July 14th. It's model scoping best practices. So if you are watching today's session, either live or on recording, I'd highly recommend the next session for you because there will be some overlap and some follow-up or some precursor. It's almost like watching a prequel before the actual movie. So next week's session will cover some of the stuff Drew's talking about in a almost in, like I said, as in a prequel note nature. And then on Friday, August the 11th, enhancing models with animation will be covered. And then the one after that will be Friday, September the 8th, and we're still working on the topic for that one as we speak. Once again, top right-hand side of the screen, you'll see the QR code there for you to scan if you don't mind and give us some feedback via the survey. So that said, Drew, the presentation is yours. I'll turn it over to you and you should be good to go.
Very good. All right. Let's see. And Dan, just confirming my screen is up and running there.
You are up and you are presenting. Maybe.
Beauty.
Yes, you're presenting. Good. Good to go.
There we go. Awesome. Okay, good morning, good afternoon, everyone. As Dan mentioned, my name is Drew Rose, Solutions Engineer here at Simio. So working with many of our customers very intimately with the product. Excited to talk today. I know this is maybe some familiar faces out there, and we might be working on a project together in some capacity. But my topic today is I'm going to be discussing how, based on your project objectives, how you can scale your Simio model to meet the needs of that project. So with that being said, we'll continue on here. All right, so let me close out my dashboard. All right, so Simio is a general use case as a simulation package where we can scale, and I'm sure many of you are familiar with their objects that can be scaled to meet the needs of your industry. And so given that we are able to scale through different industry, we can tackle and build our models to address a number of different operational and business challenges that we see in a number of different industries. So some of these challenges could involve reduction in inventory WIP, increase in throughput, eliminate lost sales, improve labor scheduling, just to name a few things. And maybe we can ask, what are the true capacity of the factory given our product mix and operational configuration? And so maybe some of these questions could say, if we were able to address these issues, maybe we need to increase our SKUs, maybe we need to have shorter delivery times, maybe if we add more complex operations, what does that pose to our system? So with all of these questions that you could theoretically ask and all these different challenges that could be set up in a Simio model, the question is asked, how do you know what is right for your project? So today we'll talk about a few user stories that are indicative of a certain model and maybe how I set up differently those models to address those specific asks. But with that, kind of to get to that point, we first need to understand our model deliverables. So before even starting a simulation model, there is a lot of precursor work that should be performed to know exactly what your focus is when starting up in Simio. So one of the key metrics of a Simio model is, who are the stakeholders involved in your project? So maybe you're the core modeler at your business. Are you modeling for production? Are you modeling for schedulers? We need to understand who those stakeholders are. And with those stakeholders, we need to determine what is critical to them. So maybe a high-level leadership, maybe they're just looking more at large cost things or certain metrics, or maybe other personnel have different asks. You need to understand who those stakeholders are, what their asks are, so that you're making sure you're going into your Simio model with the right intent and with the right outcomes in mind. And given that maybe those questions are being posed by leadership or the different stakeholders, and they have different things, we need to understand also, based on their ask, do we have the information, data, and resources to support that request? So let's say if we want to do production scheduling, but maybe our data is lacking significant detail that is necessary for production scheduling, that's where we need to go in. We need to you need to internally understand what you have as a business and also what you want to model and find that alignment point. So we don't want to overshoot our model without having an understanding of what we have available to accomplish that model. And vice versa, we don't want to have all this data that we know we have lots of resources available, but we don't have a great plan for how we're going to use that, or we don't have clear direction on the outcomes. We could try to fit a square peg into a round hole, if you will, with forcing all this data into a model without a clear intent for the why it's going to be used. And then kind of on that same point, are you going to use the model? So what is the use case, the frequency of maybe running a new plan, a new schedule, a new project? What is the intent? So match the model with the use case. If you want this to be a scheduling tool, make sure that it is in line with how you schedule, the cadence in which you schedule, the characteristics that are necessary for scheduling. That needs to be in alignment. Maybe if you're doing project work, we need to make sure that you have the necessary data at that time to meet the needs of that given project. So these are key insights that must be understood upfront before getting into a Simio model to get yourself set up for success. And really, this whole concept of model scoping practices, kind of a little precursor to the next talk. This is going to be talked at more length on how to really best set yourself up for success when it comes to model scoping. But these three, at least for my talk today, are pertinent and relevant to how I'm going with. So at least for me, these are my highlights. So now, kind of given all that background, the agenda for today is we're going to look at a few different user stories where we're going to look at the same system. So we're looking at a small shipping dock that is unloading trucks and delivering those to receiving stations. And then at the receiving stations, they then go and are stocked in a racking warehouse. And so we're going to have three different user stories with the same system, but the focus and the intent and the resourcing availability is different in each. And we'll see a little bit of the why on why I approached it the way I did, given the user story. So our first story today is a new site setup. So in this new site setup, we have a new shipping dock that is built for a future grocery store. And in that grocery store, leadership wants recommendations on the delivery policies and resource allocation. So they have the facility up and running, but we're trying to figure out how often should we have trucks arrive, and when we have trucks arrive, how many warehouse workers, how many forklifts do we need to successfully stock those raw goods from the truck. And also, given that to make these recommendations on policies and allocations, these are expensive decisions to be made by the business. So to really convince leadership, and especially those that the leadership may not have the full knowledge and background in simulation, it is paramount that animation be a part of that model, so that the leadership can truly see kind of what the changes are and see how those allocations differ and what that would how the touch and feel is different between those. So animation is a key piece in this particular model. And given that it's a new store, we're going to be limited in what data is available. We don't maybe have historical data of trucks that arrived, contents, so we have to make some assumptions. And so we have information on the volumes needed. So we have a general feel for how many pallets are going to be on the trucks. And on each pallet, we have a general feel for how many products are going to be on the pallet. And so we make we're going to sample from distributions to kind of approximate every truck that arrives, the number of pallets on that, and on every pallet on that truck, how many products are on that pallet. And so also in this recommendation, we need to be cognizant of various KPIs when we're doing our modeling. So we need to have the model be set up to study dock to stock time. So the second a truck arrives to a dock, to the second the last product on that truck is on a rack, we want to track how much time was in between. Because in a grocery store setting, at a certain point, we're going to, at a future state, once their facility is up and running, they're going to be having frozen goods, fresh goods that have a shelf life. So we need to be cognizant of the intermediate time to get it to the proper storage. Also, the number of truck arrivals. So given that we're toggling our delivery policies, we want to be understanding of how many trucks are arriving, because we're going to get charged a fixed cost every time a new truck comes to the dock, regardless of the contents of the truck. Also, the number of units delivered. So in this case, kind of that working in tandem, maybe you have a lot more trucks with smaller contents, but the units add up. Or if you have a fewer amount of trucks arrive, but they're very, very, very full, you could find that happy medium between arrivals and units delivered. And then total facility profit. So kind of adding in those fixed costs, adding in labor, adding in equipment, and adding in the anticipated value of each unit produced. We want to try to anticipate the facility profit on a certain setup. So with all this information, this is kind of, obviously there's going to be more that goes into a new project, gathering that data, time study data, a lot of different characteristics, but we're going to assume that I've done that work on my end. We know the time studies, we know how long it takes to run certain operations. We're just going to plug that in, and then really we're going to study different labor and delivery policy allocations. So when we go, we're going to start now in Simio. And Dan, just confirming that I did transition to Simio successfully.
You did. You're good to go.
Great. So in this simple model, or in this small shipping dock, we have 3 shipping dock stations that are set up for trucks to arrive to. So they'll arrive to the docking stations, and then at which time we will need a worker and a forklift to go and grab those, unbox the pallets off of that truck. And so on the pallets, or on the trucks rather, given those approximations of the number of pallets and number of products, every truck that is introduced to the system, and we're introducing trucks with a random arrival rate, something that is going to be toggled. Right now it's an exponential distribution of 40 minutes. But every truck that arrives is going to randomly sample from a set number of pallets, and then that is going to be the contents of that truck. And so when it arrives to the dock, we're going to do a kind of a math statement that says every single pallet on that truck, we're going to sample the amount of time that it takes to scan a pallet, work with the driver to verify that the order was successfully delivered, and then stage that pallet for movement to the receiving stations. And at the receiving stations, very similarly, we'll produce pallets that then arrive to the receiving station, and then another warehouse worker will go and unpalletize, remove the products, and based on that random sampling of products, they will then scan in each product, make sure their inventory is being updated, and then ultimately move that to a rack to put it to storage. So when we initialize the model, we'll get started and we see truck ID, randomly sampled 12 pallets. So the worker was called to the dock, and at a certain point, it will pull off all the pallets, and then those pallets are then grabbed by the fork trucks and moved to receiving stations to then be further unboxed and sent to storage. And so this will occur for some amount of time, and all the while we're going to be tracking metrics in the background on the time to stock, and just the overall inventory levels and various metrics along the way. So when we fast forward here a little bit further, speed it up just to further show the movement of trucks along the way. This is something that we could pose to leadership, say, hey, we get a nice visual. Here's what it looks like with 4 forklifts, 4 workers, how our system's going to respond. And also you'll see that the products here eventually get moved off of shelving after 15 minutes. We can assume maybe they're moving to the storefront in that regard. But with this animation, this is a key piece given this user story. We need our leaders to be bought into the proposals. So we need them to be able to see the visual impact of changes and how that might differ. So if you're talking to leadership, say we did one scenario with 4 workers, 4 forklifts. Let's say we do another scenario and we want to do 5 workers, 5 forklifts, and then we can visualize that change. So now we have a fleet here, the 5th forklift, and we can study the movement in that change as well. And so this will occur for some amount of time, and maybe the users are starting to see kind of how this could make sense from like where you could start to experiment with this. And that's where we'll ultimately go. So we'll go to our experiment off of this, where we're cognizant of our KPIs. So number of truck arrivals, number of units stocked, the profit, and the dock to stock time. So on our setup, we'll kind of have our pre-run here where we set up these scenarios. So we're setting up kind of this problem statement to our leadership to say, we're going to run the same system with the 16 different scenarios, toggling the number of workers, number of forklifts, and then we're going to try to find that balance between the frequency of deliveries and also the volume of deliveries. So maybe we have an arrival rate every 80 minutes we have a truck arrive, but every truck that arrives has 20 pallets on it. Or maybe we have a 30-minute delivery, but every 30 minutes we have 8 pallets on that delivery. So trying to find that happy medium and see what the right combination is for our objectives. And for time's sake, I actually ran this experiment to completion. And when we have these responses, we see that we have a minimum of 2.5 hours for our dock to stock time. So any solution that had an average time above 2.5 hours is out of scope for what our leaders have presented to us. Also, based on some cost analysis, we deemed that more than 40 trucks is going to be too costly for the business. So any solution with more than 40 truck arrivals is detrimental. Also, we found that given the demand that we have at the storefront, we need at least 1,600 units of units to be stocked. So again, filtering out more responses. And lastly, based on the profit that we are seeking, we need at least a solution that's going to pose us $8,400 of profit in the given time frame. And so when we ran this, we ultimately see that only one solution comes up with checking all the boxes for our metrics. And that's where maybe this particular animation, which really helps to reinforce the visual piece of why we're modeling, along with this experimentation, can help to pose a nice story to your leaders and really help to convince them further on why this might be a viable solution. And so that's where you can see this scenario: 5 workers, 5 forklifts, 16 pallets, 60-minute arrivals. That's where we can go and copy the scenarios to the model. And then that's where we can say, we propose this solution, and then you run that exact configuration to the model. And this is helping to build that case and say, this is why we believe X, Y, and Z based on what you set up to be our objective. So really that's kind of where I would feel that an animation is critical, is get it with your stakeholders that really need to have the visual piece to fully validate what they're seeing, maybe beyond the statistics involved in Simio. That's kind of where I see a call for the animation being pertinent. So let's say we successfully won over our executives. They are pleased with our proposal, and they're going to implement these changes when we get this system up and running. So we've completed the first user story. And then I'll pan through. So now we've transitioned to a new user story. So let's say the leadership has implemented our recommendations, and now we are running that delivery policy in those particular forklifts and warehouse workers. So let's say some amount of time has now passed, and the site is up and running. We've had deliveries for a little bit of time, and we've called upon our analytics team to groom some data for us to be able to, instead of having the distributions that we may have had in the first example, where we don't have a lot of visibility to the product. We don't really know what's on each truck. We just know that there's a number of products, a number of pallets. Analytics has produced some sample data for us to be able to work with. So among that data, we're going to get access to the truck types. So the different truck type arrivals. So there's going to be frozen goods, fresh goods, and canned goods, all with varying dock to stock timing goals, as you'd imagine. Frozen and fresh goods need to be put to refrigeration or freezer storage more quickly than maybe canned goods. And so then on each truck type, maybe there's a certain pallet type that'll be on that truck. So if you're going to see a frozen goods, obviously you wouldn't expect to have certain ingredients. You wouldn't probably have fruit gushers on a frozen truck, unless you like frozen fruit gushers. Then maybe that's your thing. And then also on each pallet, we can also have a certain product SKU that belongs on that pallet type. So if you have a pallet type of your meat, you're going to have different meats reflected on that pallet type. And so let's say we've had those leadership that really bought into what Simio proposed as a solution. So they see the importance of the animation. They kind of validated why they got really good validation on what the model is producing, and they feel good about the animation component. So they don't necessarily need to see that once again. They understand the value as a business of what Simio will bring to them. So they haven't really requested that strong animation at this time. Mainly, they want now to really dig into the statistical outputs of what Simio can produce and really see the sensitivity on how different product mixes, based on the data that we've gotten delivered by analytics, we want to see how sensitive our system is to potentially different truck arrivals. So if we have a certain truck type arrive more concentrated on a given day, is our shipping station set up to handle that? And so given that we have some data sets of historical times and what that could look like, maybe we want to look into the future and say, what could future shipments look like? So we're going to have the system be able to produce random truck arrivals for us that are indicative of what a truck arrival could look like. And then again, kind of illustrating that point. So if a high concentration of a certain truck arrives, are we at risk of not meeting our dock to stock objectives? So kind of a different lens here. We've really done those high structural decisions already, where we know our equipment, and the equipment is fixed in that regard. We know we're going to have 5 workers and 5 forklifts, but really we want to see now giving the orders in the trucks more of an identity in this model, as opposed to being approximations. So in this second model, and again, all of these are the same system in the nature. So I now have the second model where, given that the leaders we're confident in what the model is producing, what we're going to produce to our stakeholders is going to be statistical in nature. So we're going to focus on data. They're not necessarily going to be fixated on the animation once again. So the animation in this particular user story is not critical. And so that's why you see it reflected as such. And so really in the first model, we'll see kind of all the data in this animation model is just setting up our objects. So nothing that is indicative of what the data sets look like. In the second model, we now have access to those data sets that we were mentioning from analytics. So we have the 3 truck types, and then we have our pallets. So we'll see, and this maybe goes back to some few previous solution series sets you saw with relational tables and best practices there. So using those relationships, we're going to see on a frozen foods truck, these are the types of pallets that could be possible. So they could have frozen pizzas, novelty items, meat, vegetables, dinners. And by each trailer type, what types of pallets could be on that? And then taking it one step further, by each pallet type, what types of products on that pallet? So our frozen pizzas, we could have thin crust, my personal favorite, rising crust, supreme, Sicilian. And this goes on for all of our different object types, and you go on from there. And so using this, we also want to see, based on our arrival rate that we determined, when a given truck arrives, what could be on that truck. So we don't have historical data saying our list of old truck arrivals. We just know that trucks will arrive at a varying rate, and their combination mix could be sampled from all of our data. So ultimately, we've created process logic, and I won't go into it, but we have a process being created that will sample from our tables, and it'll randomly, on arrivals, we will randomly say, what truck is it? And then we'll do more sampling to say what types of pallets are on that truck, and then further sample once more what types of products are on that pallet. And so what that ultimately produces is we get this theoretical order data that now is being run through the system. So order 1, let's say, when the truck arrives, we are creating an output table that produces a potential shipment on a truck. So we're going to see pallet 1 has a package of pork, and chicken. So that's pallet 1. That'll continue on for each pallet, and we're numbering the products on each pallet, and also what is the different items on that. And so this will be compiled, and how this will differ from the previous model is in making those approximations. Let's say we had a distribution of it takes on average 1 to 3 minutes to scan in each product, and we do that for each particular product on a pallet. So again, kind of low data fidelity in the animation model. But in this case, our docks are set up we're going to validate the arrival with the driver. That'll occur with the warehouse worker. We're going to scan pallets, and then we have a process that'll look at the compilation of that potential order, And based on that order, it's going to say, okay, this has an order of chicken, pork, on that particular pallet. And we know based on the data set, how long it takes to scan that particular item. So let's say we'll go back and we'll look at pallet 6 here. So on pallet 6, we see there's 2 units of onions, 1 unit of lettuce, 1 unit of peppers. And based on that setup, we know that it takes 1.76 minutes to fully validate the onions, make sure the expiration date is met, all the different operations. We're tracking that specific time for that specific product. So really digging into the fidelity of the model. And so all these compilations can be custom in nature. And so that we're going to get a true sampling of what could be possible in reality. And so when we run through this and we start to produce this data, we can see all these truck types, all their contents. We're going to run them through the system as it's set up based on our first experiment we did with our first user story. And we're going to see, does that particular truck's dock to stock time pass or fail its objective? And so our truck type, our frozen foods, we have a goal of getting it to the shelves in under 0.75 minutes. Fresh produce under an hour and a half. Canned goods under 2.5 hours. And so we're gonna track the time and system against that goal to see if it passed or failed. And so you can run this through, and then ultimately you see a large list of all the trucks and the anticipated time and system. And that's where we can start to, and that's where we can go and we can show these dashboards to our leaders and say, we're seeing the average dock to stock time vary by product type. So fresh produce based on this sampling is taking the longest for us to get to shelves. And we can start to dig into why. And maybe we have a shelving goal for each, and we see maybe it takes longer for fresh produce, but we have more window to get it to the shelves. So maybe this is saying it takes a less amount of time to get frozen foods to the shelves, but they have a smaller window, so we fail more with getting those to the shelves. And we feel good about our process for getting canned goods to the shelves. And also we can study, again, kind of using our periodic statistics from our previous solution series sessions. We can see if there's any daily trends that might help to identify why things might be failing so much as far as getting to shelves. And also with this, we can run experimentation. So maybe we run this analysis, but we want to take it a step further and really dig into some best optimistic, pessimistic scenarios. So in this particular experiment, we have these frozen truck percents. And if any of you have ever done kind of using your mix columns, these percentages will be added amongst each other. And then this individual percentage will be divided by the total to get a percent allocation of arrivals. So let's say all these three, that the percentage adds up to 3. Frozen truck divided by total is 33%. So 33% of our trucks in this scenario will be frozen, 33 fresh, 33 preserved. So it's just giving it a weight factor. And we want to see, based on different concentrations of arrivals, let's say now 50% of our arrivals are frozen trucks. How will that impact our on-time putaways as a percentage? How much time are they waiting to get to the dock? And the average dock to stock time. And so again, we can run through these scenarios, optimistic, pessimistic, and see if we get a large shipment of a particular truck type, are we at risk? And so you look and everything seems to be okay, but in the scenario where we have only frozen trucks, so if there's maybe there's some particular event that is calling for us to get a large shipment of frozen trucks all in succession, our on-time putaways is below 50%, we could be at risk of really not meeting our goals on on-time putaways. And our system might call for us to really rethink how our system is allocated. So we certainly won't go into that today, but this is indicative of maybe some sensitivity analysis that could be performed at your site on different product mixes with using the data sets and sampling those and giving more identity to your orders. We can see kind of a nice strain analysis on if a particular order type, order set is going to be detrimental when fed through your system. So let's say we tackled that and we did some sensitivity analysis. and maybe there's some concerns from our leadership. And so based on those findings, we see that we have close to 40% put away success with frozen trucks. That calls for leadership to want to ingest true shipment data from a fleet management software and really have Simio run through actual truck orders to see how it should best structure those orders. And so now we get provided, because we're assuming we're pulling in the relevant data at the time. So our truck dock is opening up at 8 a.m. We're pulling in a list of the truck shipments that are set to arrive on that day, that need to be scheduled, that the arrival needs to be scheduled for. And also we have information on the true contents of that truck. So the previous model, we were making assumptions. We were doing some sampling to kind of make sample product truck mixes. In this case, we're getting actual enterprise data that is true in nature and is actually going to be in occurrence, not theoretical in nature. And so we need to figure out how we should best pick one truck from another when figuring out what truck should go first in our system. And based on what we were seeing previously with our sensitivity, our shipping dock is underperforming. We're missing our dock to stock goals. We need to get better about how we are deciding when our trucks should arrive. And in that product mix we've been alluding to is posing challenges to determine the optimal schedule. We're not sure, do we schedule the truck that has the most pallets first? Is that the first to arrive? Do we always schedule the trucks that are frozen? Do those go first? What are the rules that should help to govern how we determine when trucks should arrive? And so we're really trying to figure out how to do that best scheduling to hit our KPIs. And we're seeking some policy review on criteria for planning arrivals. And I won't thank you just yet, but in short time. So in this third scenario now, we're kind of looking at it from a planning lens. So we're going to again depend on that data. Where let's assume that we have a connection to the fleet management system of our enterprise, and we've pulled that relevant data that shows the trucking shipments that have been released for scheduling today. So we have 10 trucks that all are posed to us at the same time, same even platform. And on each of those, we also have the contents of each. So very similar structure and nature to the previous, where we show what's on that truck. So we have our frozen pizza truck, our seafood truck, the fresh fruits. So all the attributes of those, we're going to try to consider all these details and really try to make a best decision on when should we bring each truck to our system. And that's where we introduce the concept of these dispatching rules. And that's where these policies that can help to sift through the attributes of your data and help to comb through that and make best guesses and make best decisions really comes into play with these dispatching rules. So when our trucks arrive, and in the previous case, we had trucks arriving randomly in nature based on our first study. In this particular model, trucks are arriving based on our schedule. So everything is released at once. So all 10 trucks are available to be moved through the system. But really, we need to govern, and we only have so much dock space, so we can't release them all at once. How do we make that decision on what truck goes next? So with those dispatching rules, we can start to play with that. So let's say we set up some rules, and based on the attributes of our data that say maybe we want to schedule against priority. So we're going to say each truck shipment, based on the customer, based on the detail, maybe has a given priority based on what's on that truck. So that could be one criteria for scheduling. Other criteria could be the number of pallets. So the largest attribute, so the trucks with the most pallets, those get scheduled first. Maybe another one is the smallest dock to stock time. So that's another metric we compare against. So all of these different criteria is how do you determine what's the best? And then also first in queue. So that would just be looking top down at that data set. So not really much analysis in that regard. So with all this, we could start to play that game and see what is the right policy for us to meet that dock to stock time goal. So when we run our first model through, and we'll fast forward again because our leadership is bought into animation, they don't need to see things flow through the system. They've gotten that validation in the first model. they're going to use the planning model, and now they're going to look at our outputs. So we ran our 10 orders through, and we start to just study what is the pass fail rate. So based on our first criteria that says, I'll pause. So our first criteria says we're gonna schedule against priority. So our priority is, let's say, order 8, highest priority, that should be the first to be picked. Then we should have order 2 and order 6, both priority 5, those should be next up. And we see that to be the case here. Order 6, the first to be written to, the first one put away. And order 2 and order 8 are next in line. But when we run through with that procedural behavior, we see that we have 4 orders failed. So maybe based on our KPIs, this is not acceptable. We need to rethink how we're dictating our order cadence. So maybe we rethink things, and now we want to instead we want to study the dock to stock time. So anything that's all of our frozen items, we want to be the first to arrive that day, just so we are guaranteeing more resource availability. So we'll put that to the top of our list as far as our decisioning rules, and we run that through again. We now see that we pick different orders. So now we'll see all of our frozen foods go first, then our fresh produce, and then our canned processed goods all gets through. And then maybe for some rhyme or reason, the 10th order took a while to get onto the shelves. But doing this procedural change, we see then our pass rate went up from 60% to 80% by just prioritizing our perishable items for selection. And so maybe that could be something we say, okay, maybe this should be a new policy that we consider. Let's get more data. Let's feed this through. Let's continue to do some testing to see what is going to be best for the business. And we'll do it once more just to continue to try to find that perfect value. Maybe we just want to test the number of pallets. So our biggest orders, we're going to get out of the gates first. And we see again, our canned processed goods, those get selected first. Those both, and I'll give you a spoiler alert, those both have 13 pallets on that truck as opposed to 12, so those get selected first. But we see doing it this way, we have 3 failed dock to stock times as opposed to 2. So maybe that's not best for this data set. And so this is some analysis you can perform and really try to find what is best decision policy for the business. And there's certainly a number of options that you can do as far as what criteria do you want to study for order planning. So it could be conditional. So we could set up all these different expressions to kind of test our one order from another based on that order information, and really try to find the true business rules that dictate how we should strategize one order being placed in front of another. So with all that, like this would be causation. So maybe let's assume that we've optimized our policies, and now kind of the next step where you could continue to go with this user story is now we want to create a work plan. So we have trucks arriving, we know what cadence they should arrive in, and now we want to create a task plan for our workers to say, hey, warehouse worker 1, here's what resources are coming today. These are the items that you should be working on. And that could be the next level of fidelity, the next level of user story, and where we're further pulling in the proper information to govern that, to help with that model journey. And we can continue to scale and build our models around our user stories. But with all that being said, that's about it for my content today. All in all, just hope you can kind of see with the same system how these different user stories might play into effect what decisions you need to make on how to set up your model to accommodate the different asks of your model, the different data available, and what you're hoping to present to your stakeholders. So with that, I'll thank you all for attending today, and if there's questions, happy to field those at this time.
Great, thank you, Drew. And actually, there's a list of questions here, so let's get right into them. As I'm going to start to read the questions off, If you are in attendance and you have a question and you haven't asked it yet, feel free to type it in the question box. All right, let's start at the top. How can I use Simio to run a year-long analysis? And the question, how can I analyze, for example, different work shifts defined in different schedules, day and night shifts, run the model for a year and do a month-by-month analysis? I know that's a mouthful, but that was the question.
Yeah, absolutely. So off the jump, you have the ability to kind of define the duration of your model run. So this could be a 24-hour analysis, it could be a year analysis. And then depending on the cadence, and you mentioned some monthly analysis, that's where I would recommend our use of our periodic statistics. So I created one for daily analysis. You based on what your period is defined as, you can set up a periodic statistic to do that analysis on a month-by-month basis. So if let's say you're looking at forecast data for 2024, every month you could see trends that might govern things that happen. So let's say the summer months, we have work schedules, we have more workers out based on our work schedules function. So we've incorporated work schedules of our personnel. We can see the summer months, maybe our throughput might lag due to that. So that's a potential insight. But yeah, fully capable there.
Great. And obviously, as we address these questions, if we don't address something fully, I will bring up the slide with Drew and myself's email again at the end, so you can always come back directly to one of us. Next question, I'm going to answer this one, Drew. The question was, could someone reiterate how this recording will be shared after the session? So on the Simio webpage, if you do want to go back and watch this session over, shortly after we're done, once the download is completed, we will publish this recording on our webpage. It will be right under the Solution Series spot on the webpage. So you can go there, click on it, and you'll just be able to go and watch the entire thing from the start. All right, back to you for your questions, Drew. How can you overlay different responses to execute sensitivity analysis to minimize a specific KPI? For example, overlaying CO2 truck emissions over the whole manufacturing process to minimize overall emissions.
Yeah, so that's where in our ability to create these processing tasks and we have example models that show kind of that tabular behavior on processing tasks. That's where you can define any ancillary actions that occur at each process. So if there's certain operations in your manufacturing execution that let's say that running a machining operation is going to produce X number of pounds of CO2 per usage, we could put in a policy that says every time this machine is run, that produces so many pounds. And then depending on if you feed through data that makes the machine more utilized, that'll in case produce more CO2. So maybe depending on your volume, that could help to really spell out some sensitivity of where your CO2 emissions could be more concentrated.
Great, thank you. And once again, if I did not interpret your question correctly or we don't answer it in its entirety, you'll see our email addresses here at the end. Drew, calibration. How can users calibrate the model's controls and validate it?
So that's where, depending on your objectives, kind of what I did here is I handpicked these values for my experimentation. But if you're really not quite sure on how you want to hone in on these, that's where a use of this Quest optimizer, and there's follow-up literature in different help docs describing this functionality, but this optimizer can run through different scenarios to consider the multi-objectives of your statement and hone in on those on the particular scenario that is best meeting your KPIs. And so that in this case where I had 4 objectives and I could have theoretically a number of different rates, that optimizer will auto-generate those scenarios for me and kind of hone into the true values.
Perfect. And I think you might have just addressed the next question, because I think this is a follow-up to that one, but can you use any algorithm to optimize your system, and what algorithms can be used/defined to optimize integer variables?
Yeah, that's right. I would lean on the optimizer in that case, and instead of having to sift through experiments, that's where it can go in and run those for you to try to find that best policy for the business.
Great, thank you. What other methods are there to track individual entities on pallets if they're not modeled as entities?
Yeah, so and it comes down to how you'd want to study, like what attributes of that pallet contents you'd want to study. So we see cases where we can model things as generic entities, but there's a material element applied to that entity. And when it's put to a shelf, it is producing a unit of that material that is indicative of that particular product. And so you could kind of use some material consumption, production, and that in the material element, and I'll quickly pan to that. The material element gives you a lot of nice insights as far as kind of different quantities, properties, and there's a lot of metrics you can pull from your material element. So that I've seen cases, and I myself have used that material being a nice instance of, instead of having to model out a part entity, having the material element kind of do that work for you.
All right, great. We're starting to wind down on questions, not wind up, wind down. A follow-up to the optimizer question. Can you change the underlying logic slash algorithm that it uses? For example, are there different methods you can choose, different algorithms?
That I will have to review. As far as the OptQuest optimizer itself, I know that there is literature on that. I'm not the best to speak to the changing of it. I just know directly within the product that is not capable, but I will follow up.
All right, that's great. Perfect, appreciate it. Last one. Where would you suggest users start modeling within Simio? Do you suggest starting by placing objects in the facility, defining data tables and properties, etc.?
I guess it really just comes down to, again, the user story. Like what are the objectives of your business? Like what is your system? What problems are you facing? Again, what availability do you have? Where's the initiative coming from? Those are questions that you can ask to really guide you towards somewhere starting. And certainly we always recommend kind of a data-driven approach where possible. So formatting things, kind of hosting all of our objects in a data table, and kind of having it host all the logic, we always recommend is a strong approach, and really one that's scalable in nature should you want to mature your model in some regard. But it comes down to what you're after. Certainly the animation model doesn't have as much data dependency, but that doesn't make it any less effective than either of the other models. It's just the scope of the model was more broad in nature, therefore the data need was less in nature. So it is situational in that manner.
Okay, another question popped in, Drew. And this is actually, I think, a good question for everyone to hear addressed. For a data scientist / engineer that's brand new to Simio, are there pre-baked data sets that they can use to self-teach functionality and processes? I guess basically SimBits. You want to talk through those?
Sure. Yeah. So we have a few example models in our repository that make use of our ISO 95 templates. So and I'm not going to create a template, but a common structure or recommended structure to kind of get you closer aligned to manufacturing systems, which is generally ISO 95. These templates really give you a sample and flavor for what type of data might be relevant for a Simio model based on your objectives. In this case, and we'll go to planning model. So like truck shipment data, like this is pulled from a template where these are some attributes of an order that might be seen with tech systems in the field. So I would first go to these examples and kind of sift through those and study the data sets, because those are going to be structured in a way that is what we view as best practices for those given models.
Great. All right, I think the questions are winding down. Drew, I'm going to grab control back here real quick. and just bring up our email addresses so everyone has them. And I'm actually going to go back to this slide right here. So as I asked earlier, or as I'm bringing up here, so top left side of the screen is a QR code. If you're watching this now live or you're watching this on recording, if you could scan that QR code and go in and complete a quick survey for us, we'd greatly appreciate it. Just so we get some feedback on how things are going and if there's things we could be doing differently or if things are going the way you would expect them to in these sessions. Email addresses, there's mine, there's Drew's. Pretty simple on Drew's. Mine's a little more difficult, a couple more vowels in mine, but Drew's is nice and simple. drose@simio.com or dvasilini@simio.com. You can reach out to either of us. If you asked a question today and we did not, either I did not interpret it correctly, or if we didn't address it in its entirety, feel free to reach out to us and let us know. Otherwise, one last check on the question box. I think we're done. Thanks everyone for attending today. Bring up one more time here. So about a month from now, July 14th, as I said, the prequel for this session will be on July 14th. I'd recommend everyone that's either watching this live or watching this recording, please come and join us on the 14th. As you can see, an advantage of attending live, you can ask questions directly while we're here. You can get things addressed hopefully in real time, and you can also reach out to us right afterwards. So thanks everyone for attending. We appreciate your time today. We look forward to seeing you again in about a month. See y'all. Good job, Drew. Bye-bye.
Thank you, everyone.